You can see in this artistic representation of our group's corkscrew the momentum in red, the centripetal force in green, and the force of friction in pink. The centripetal force pushes the marble towards the bottom of the track. If there were no centripetal force, then the marble would fly off the track due to its current momentum. At this point in the roller coaster, you can tell that the marble is at constant acceleration because the marble is moving at a constant velocity and not changing its speed or direction. It's traveling in a straight line at a constant speed, and it's not accelerating or decelerating. This image depicts a marble on a ramp, as well as the forces acting on that marble. You can see the force of friction, as well as the normal force and the force of gravity acting on the marble. You can also see the future tangential force of velocity. The tangential force of velocity is a force that's experienced by any object caught up in a circular motion. This force is representative of the direction that the object would fly in if the centripetal force causing the object to stay in that circular motion were to suddenly disappear. In this case, that force would disappear when the marble flies off the ramp. Then the only forces acting on it would be the tangential force of velocity and the force of gravity. The forces acting on the marble aren't bounced during this time because the centripetal force of the funnel pulls the marble inward. This physical change is also proof of the fact that the forces acting on the marble at this time aren't balanced. You can see the tangential force, which represents the momentum of the marble directed outside of the sphere, as well as the centripetal force pulling the marble towards the center of the sphere. In the first section of this graph, we can see the marble decelerating. Decelerating is the loss of momentum. This is due to the shifting direction of the normal force on the marble as the marble begins to climb up the loop-de-loop. This, in tandem with the constant downward force of gravity and the force of friction, result in the marble slowing down. At this point in time, the marble has decelerated to a degree that it's almost at a complete stop. The normal force has begun to align itself with the force of gravity, which will cause the marble to accelerate downward. Tangential velocity at this point in time is pointing straight, although there's very little tangential velocity to speak of. This is the only instance in this graph where it is impossible to calculate the magnitude, because it's the only time in this graph that the magnitude is at least not greater than the force of gravity. After the marble reaches the peak, it begins to accelerate downward with increased speed due to the shared direction of force of the normal force and the force of gravity. Along with the normal force, the tangential velocity begins to increase once the object starts accelerating.